Okay, so welcome back. This is the third lecture. Today we're going to talk about essentially the third lab sheet, which is something that I'm hoping that you will work on next week. Okay, so by today's lab session, hopefully you should have finished with building your first virtual machine in the lab. Ideally, I would like you to have your cloud configured and everything. I would like you to have the one virtual machine built from its template, its images, network card, and everything else. And hopefully you will have actually tried the networking on it as well. So I would like you by the end of this lab sheet, so as a proof of that it's working, for you to actually open a terminal and ping google.com from inside that virtual machine inside OpenNebula. Okay, if you missed that last step, all you need to do is basically go inside your virtual machine that's running inside OpenNebula, go into the network card settings, and give it exactly the same settings that you gave to the network card that you created inside the cloud. So you should be using the second level bridge IP address for that virtual machine, inside that virtual machine. So if your actual computers have an address of 0 to 48, your Prometheus VMs from 1 to 48, your Prometheus VMs will have 51 to 98, then your virtual machines should have 101 to 148 as their IP addresses. Then they should be able to ping Google and basically do everything else on it. Okay. Now, since you have a virtual machine working inside your cloud, this means that we can now go around and try and familiarize ourselves with the management interface. Now, OpenNebula itself, as a cloud software, can be run and can be managed even on a command line. So you don't actually need a web interface or any other sort of interface in order to start up your virtual machines, configure them, and so on. However, this can get very technical. Okay, so that's why we use the second component and the second most important component of OpenNebula, which is Sunstone. So when you're trying to start up your cloud, two things are required. So that's something that you do in the first and second lab sheet. You run the OpenNebula service and you run the OpenNebula Sunstone service as well. The Sunstone service is the web server that basically lets you manage your system. Now this web server has three different types of views. You will only have seen the one type of view so far. You will only have looked at it as admin. The idea behind the cloud is you build the general cloud infrastructure as an admin. Then, depending on the size of the company that you're building this for, or the organization that you're building this for, you might need to break up that cloud into various smaller sub-clouds. Okay, so we call them virtual data centers inside that cloud. So let's say, for example, if the University of Portsmouth School of Computing had a cloud in OpenNebula, which we do, all right, then you would possibly split this into multiple areas. So you would have an area that would be admin testing. So your admin accounts and all of the super users can actually build and test virtual machines there so that they can do some development work in order to deploy them to the final customers. You can have an area which is called academics. So all of the lecturers can have their own virtual machines inside that cloud, and they will have an admin account. So somebody will be the administrator account for this, and he will be able to administer all of those virtual machines. You could have another area, another VDC that's called students. So then you have virtual machines that are provided to the students so that they can actually log in and do some work. You can have another area called research for all of the researchers to be able to actually use computers in the cloud, and so on. So virtual data centers inside the OpenNebula infrastructure itself is a very good idea, because that way you can split your resources and you can allocate as many CPU cores, or the amount of memory or amount of hard drive, or different network cards which provide access to different networks, to different computers inside different virtual data centers. And the third and last view that you can have is the simple cloud user. So this is your end customer's view. So this is what whoever will be using the cloud and probably has no idea how to manage anything, and they shouldn't really care about it, this is what they see. They should go onto a website and then they should just be able to click on the virtual machine, start it up. Possibly, if you let them, if you give them the correct permissions and flexibility, they could run a virtual machine and they could say, I'm going to need a little bit more power for this. So instead of using one core, I will give it a second core as well and let it start. Okay, so you can configure your templates in such a way you can most importantly, configure the permissions of that template so that the end users can actually make changes to that virtual machine, or they can just run it and use it, and that's it. It totally depends on the use case every time. So it depends on what you actually want your users to be able to do. So in our specific example with the university, you probably don't want your students to be able to make any changes, or your members of staff for that matter, but possibly the researchers that know a little bit more and might need some more resources at some time. If they run a simulation that needs lots of CPU and memory, then they can add resources to the virtual machines, or they can start more instances of the virtual machine that they're running at the same time. Okay, so it all depends on what you actually want to be doing with your customers. So we're going to look at these three different views. Basically, this lab sheet is different to the rest because it's a little bit self-guided. The idea behind this lab sheet is to force you to click on everything inside the cloud. Okay, I want you to click on all the boxes, click on all the options, click on everything and see what it actually does. It's still early enough that if you actually break something in the cloud, it doesn't really matter. We can just recover. Also, it's a good idea before you start working on this lab sheet to take a backup of your system so far. So your Prometheus virtual machine at the moment will have OpenNebula running and will have a virtual machine configured and running correctly without any other configuration. All you need to do is go to your host, go into your VMware folder in your home directory as user VM3 or VM4, and find your TB2 Prometheus folder and make a copy of it somewhere else and name it backup, and then put a date maybe, or call it lab 2 backup. All right, you play around in lab 3, you mess things up, you don't care. You delete the entire virtual machine, you copy the backup back into its place, you start it up, and you're there again. All right, so it's a very important thing for you to do before you start with the third lab set. Now, things that I definitely want you to try for the third lab set are, for example, the main VM actions. So the idea behind this is that a virtual machine in the cloud doesn't only give you the option to have it running or not running. It can be running, or rather it can be not running, in various different levels and states. Okay, so for example, if you hit suspend, then the virtual machine will go to sleep. It's as if having a laptop, you close the lid, everything is still running, okay, it's still wasting battery and stuff, but it's not doing anything, it's sleeping. All right, so this is the same state, it's suspend. If you power off, it will power off a VM, but it will keep it in the virtualization host. This makes a difference because it still reserves the resources in the cloud. If your virtualization host, let's say your Prometheus VM, has 4 CPU cores available, and you have 3 virtual machines that are running, and you want to start 2 more, you cannot. Okay, if they're all using 1 core each, eventually you're asking for 5 VMs, 5 cores, you only have 4 cores to give. If you think that you can power off one of the VMs, and then that will release a core, it will not. Okay, the core will still be kept, used by that virtual machine. The virtual machine will be off, but at any point you can hit play, the little blue play button, and it will start up again because it has reserved the resources and it has the CPU and the RAM and the network cards available to start. Okay, if you power it off, it stays there and it's simply shutting down the computer, shutting down the virtual machine. All right, it gives you the ability to start it right back up. It has saved all of the data, whether the disk is persistent or not, and it's ready to use straight away as it was. If you stop it, then the virtual machine state is saved and it's taken to the system data store. So that will release the resources. That will still save everything that you've done inside the virtual machine. Okay, but it will take it onto the system data store and it will store it there until you try to instantiate it again. So that instance will disappear. All right. If you undeploy, it powers off the VM and it takes you to the system data store. So again, it releases the resources. If you reboot, it reboots. You can delete, and then you can recreate as well if you want to. So that will clean the VM and will move it to status pending. So basically to delete it from the system. The important thing to note here is whether your data is actually saved or not. And this is what I want you to test on your virtual machines. I want you to create a file somewhere in your documents or downloads or anywhere. And then after you try all of these buttons, see if that file is still there. Okay. So you can shut down hard, which powers off the VM, cleans the host, and the VM is removed from the OpenNebula completely. And then you can also delete it, which means that the VM is immediately destroyed, regardless of the state, and it's only recommended for one admin users. It doesn't make too much difference, and at the moment, because you're logged in as one admin, a couple of these states might seem the same, so shut down hard and delete will actually be the same. Okay, but if you log in as other users, if you log in as a simple user, you will see how many of these options you actually have available to use and how many not. All right, so I do want you to play around a little bit with this and understand the different states that you will have for this. Logging in as different users, you can do it later on because we do create other users. We do create a student user in this later on. So you can come back to this page and try and see which of the different state buttons you actually get as a normal user and which ones you do not. Other actions that you can take have to do with the virtual machine themselves and how flexible they are with regards to what they actually use. For example, you can have a virtual machine that's running and you can add a new hard drive or you can remove an existing hard drive as long as it's not the operating system hard drive, okay, from the thing. For example, your first virtual machine has a DVD on it. It has the CentOS DVD. You can delete it. You can remove it even while the VM is running. Okay, it won't delete it from the template, but it will delete it from the virtual machine itself, which also means it will release the space on the system data store that hard drive image was taking. So those 4.5 gigabytes will be deducted from the space that you're using wherever you're running that virtual machine. Okay, so if you wanted to save some space on your running virtual machines, you can remove images that you don't actually use, that you don't actually need. And the DVD, for example, after you've installed the operating system, you don't need it ever again. So you shouldn't really have it. Ideally, you should go to the template of the virtual machine and delete that second image from there because you don't need it anymore. All right. Network, you have the network cards. You can delete the network card from the virtual machine. You can add another network card to it. You can have 2, 3 network cards, whatever you like. Again, you can try this simply by creating a network card. Create a dummy network card. Don't give it any IP address or anything else. Just let it exist there and just see if you can attach this network card onto your virtual machine and then remove it as well. You should be able to take snapshots. However, you might not. Okay, and this particular bit of the lab sheet I don't really want to help you too much with. I will only give you the hint that at the moment, with the way that the VMs are built, you cannot take snapshots. Okay, what I want you to do is I want you to figure out why. Okay, you should theoretically, there's a button, snapshot, you click and it should just do its thing and make a copy of the VM and, ready for you to have a backup of it. It will not. All right. And capacity, resize VM capacity as well. When we're talking about the capacity of a virtual machine, we're not just talking about hard drive space, we're also talking about RAM size and CPU cores as well. So what I mentioned earlier about the researcher deciding he needs more cores, you should actually be able to do this live on the running virtual machine as well. Okay. Permissions. So there is a table of permissions for every component in OpenNebula, whether it's an image, whether it's a template, whether it's a user or a group of users and so on, and they all look like this. Ideally, you should have in your logbook a little table or a bigger table with the users that you want to create in your system, where they belong, and what you want them to be able to do. Okay, so if you want your users to just be able to start up virtual machines, you should say that user John belongs to group students, and the students only have use access to the template student PC1. This means that they can only start it and stop it. And when I say stop it, I mean shut it down, not even delete it and remove it from the cloud as well. Yeah. So it's very important that you understand the permissions for everything. Once you create that first student account, and if you try to start a virtual machine, the first thing that will happen is you will not be able to see the virtual machine itself when you log in as student, because you will need to go back to the template or back to the instance that's running, change the permissions, and let that particular student account be able to actually use that virtual machine. Okay, so you really need to think about not just the virtual machine on the top level, but all of the subcomponents that make up this virtual machine, the network cards, the images, the template that governs it, and everything else, and make sure that you apply the correct permissions to every component in the cloud. It's tedious and annoying, but that's why you use groups and you don't have individual users. Okay, so if you allocate the users to the correct groups and then you manage the permissions of each user within the group, then that should make it fairly straightforward to do. That's why when system administrators have users that ask them to be able to do extra stuff, they get annoyed, because it means that they will need to differentiate a specific user from the rest of the group, and that is just a hassle. Okay, it just means more work for them, because they need to make the changes, make a log about the changes, put a notice on the system somewhere and say, all students are allowed to run 3 VMs, but Vas, because we like him, can run 4. Okay, so there's things like this that can make the management of the system a little bit more tedious. So try to keep it as simple as possible, all right, for your own peace of mind and mental health. So groups. The first group that I want you to create is I want you to create a group called students. Okay, make a students group and then make sure that you check the permission tabs for that students group and make sure that you see what they can and cannot do. And very importantly, make sure that you create a students admin account. So when you create a group, you name it students, there will be a checkbox in one of the tabs, look for it and find it, that will ask you if you want to create a students admin account. That students admin account will be the VDC admin for the students group. So it will be a second level administrator user specifically for that group of users that you just created. Okay. Set all passwords always to localhost 1 so that we don't have to go around and look for passwords all the time. Okay. I was very impressed this year with this class. I only had 4 students that forgot their passwords from the first week. So yay. Previous teaching block I had about 20. So okay, so access control lists. So again, it's about permission. So when a group is created, a new set of ACLs are introduced, and it tells you which virtual machines, which templates, which networks, and so on the users in those groups can actually manage or just use or whatever they can do. So make sure that you study this and figure out exactly what it means. So make sure that the permissions for your group is correct. Now, once you have all this, you can basically change views and go into VDC admin view. So you can log in as students admin. Once you log in with that account, once you log in with the students admin account, you should be able to perform some administrative tasks, but you will not have as much freedom and you won't have as much access to information as the one admin user. So for example, you might not be able to see the hosts that are running all the virtual machines on the cloud, and you might not be able to see all of the individual networks that exist and so on. Okay, so the little menu on the left-hand side of Sunstone will be shorter. All right, so you log in as student admin and you create a student. You call it whatever you want to call it, and you assign quotas to the student. You say this student can have 1 CPU, can have up to 4 gigabytes of RAM, up to so much hard drive space. He'll be able to use those images and he'll be able to run those particular templates, and that's it. For you, at the moment, it's very easy because you only have one of everything. Okay, you only have one really image that we care about, and that's the hard drive block that you've created. You only have one virtual machine, which is Prometheus 0. and you only have one network card, which is the bridge network card that you have. Okay, so make sure that you let your user, your student that you've created, be able to actually use this. And if you do this correctly, later on, when you actually log in as the student, you will be able to see the little icon with the virtual machine, and you will be able to run that virtual machine as a student. The one thing that will definitely go wrong here is you will click on this virtual machine and it will say no. All right. It will have a little red box next to it that pertains to the images. And if you look into the logs and everything, it will say that image is already in use. You cannot use it again. The reason for this is because as one admin, you have already instantiated vPrometheus 0, and the hard drive of vPrometheus 0 is persistent. So the images that you're using are persistent. So it means that that image, when it's running in one instance in the virtual machine, is getting written on and read from. So any changes you make to that virtual machine will stay in that virtual machine. You change the wallpaper, you create new files, everything will be there. Okay, it's a hard drive that is as simple in use as possible. All right, it belongs to one virtual machine and that's it. So you cannot instantiate it a second time. You can create hard drives that are non-persistent. So this means that they will boot up and they will start, but everything that you do to them, any changes that you make, once you deinstantiate the virtual machine, once you stop it, they will get lost. However, you can run as many instances of this as you like. So if you have 1,000 students in a school and you want them all to be able to run 1,000 virtual machines in your cloud at the same time, you create one template, which is the student PC. This is what the students should be able to see. You install whatever software you want on it, you configure whatever you want on it. Okay, and it's running in the system as non-persistent mode. Okay, so the template exists and all of the ingredients are there. So whenever a student wants to use it, they instantiate it, they start it up and they use it. They can start another one and another one and another one. That image of that hard drive gets copied and copied and copied and copied and copied every time a new student creates a new instance of that virtual machine. When they shut it down, the images get deleted and deleted and deleted and deleted, and the students lose everything. Okay, this is fine because this might be a virtual machine that you're running in the cloud for someone to do their work, produce some results, and then shut it down and delete it. Now, those results, that data that they will create, you have the option for it to be saved in their local user account. If you log into any of our computers in the university, whether you log into a Windows machine or to a Linux machine, your home folder is never located on the computer that you're on. Your home folder is a directory that's somewhere on one of the 3 data centers that the university has, and it's accessible over the network. That's why if there is no network for some reason, you won't be able to log in. First of all, you won't be able to log in because we use central authentication. We use LDAP and Active Directory. Okay, so you log in, you get a hard drive, which is your local C hard drive or your /root whatever. You get a second hard drive next to it that says UP123456, and that is where all of your data is stored. So with the same configuration, if you instantiate a non-persistent virtual machine in the cloud, you map the network hard drive onto that virtual machine because you've configured that template to do so. The student saves all of his work in his home directory by default, so the student doesn't actually need to do anything. And when they stop the virtual machine, when they shut it down and go away, all of the data that they saved is saved in their home directory, and everything else that has to do with the virtual machine's operation, cached files from the programs that they were running or anything else, gets deleted. Okay, so that's why you will not be able to run the virtual machine if you just log in as a student. If you want to test it, log in as one admin, or before you log out from one admin, just make sure you go to instances and delete, using the red button with the bin, the virtual machine that's running from there. It will not delete anything, because that hard drive is persistent. Okay, so you won't lose your installation or anything. The running instance of the virtual machine will simply disappear from the cloud, and it will release all of the resources of that. Primarily, it's the image that we're worried about, and you'll be able to use that image for the virtual machine that you will start as a student. Okay. Play around, see what options you have and what options you don't have as a normal user in there. Theoretically, you should just be able to start a virtual machine and stop it and nothing else. All right. And you should be able to see some graphs that have to do with the performance and the usage of resources from the system itself. It won't actually look exactly like this because the screenshot was taken on version 5. Okay, but they will look like a graph with a line and so on. All right. And that's pretty much it. These are other features that you can play around if you like, so you can explore in OpenNebula. Okay, but they really are beyond the scope of what I want to do with OpenNebula for this particular model. Okay, so first of all, the fact that the lab sheet is a PDF from a PowerPoint and it's landscape doesn't mean that you don't have to do it. Yes? I've heard this so many times. Marking logbooks and then this lab sheet is not there. The students lose 10 marks and like, but it was a PowerPoint. But you have to do it. Okay, so just to get this out of the way and make sure, yeah? This shouldn't take you too long to do. All right. Ideally, I would have liked, and the only reason why I don't do it is because not all of you are here. So that you get an idea of what's happening. The lab can fit 96 students. The number of students registered in the module keeps going up. I now have 117 students registered. Okay, so those extra 21 students haven't shown up. All right, so I want to start slow, but then I will make sure that before we go for Easter, probably before even we close for the consolidation week, I will have delivered all of the lab sheets. Then you can use all of the rest of the month and a half that's remaining for the last lab sheet / coursework for this. Okay, so that's why I didn't deliver them all in one go. If you think that you've done everything, please make sure that you take screenshots of everything, that you document everything correctly. And it's very important that you train yourself to do this efficiently and progress a bit slower, because later on when it does actually get difficult, and it will get very difficult, to the point that I will basically, the next lab sheet is I will show you how the networking works, and then after that I will tell you, build me a cloud, good luck. Okay, so things will get complicated. Make sure that you have the ability to take screenshots, you figure out all the shortcuts and everything that you need on your keyboard and everything on the system of how to actually take screenshots, and progress and make sure that your logbook is in a good enough state. All right, also remember to have a look on Moodle at that video that I have about how to actually make the logbook. All right, and of course, if you make a couple of lab sheets and you want me to check your logbook and see what it's like, see if you're doing it correctly, you can either ask me in class or you can send it to me on an email and I'll have a look and give you some feedback on it and tell you if you're doing it right or not. Okay, that's it for today.